All right, guys, I'm gonna kind of catch up a few more things on 24 through 26, and then I will post a few more tomorrow. It seems like all the videos are working much better now, and so remember, these all help you guys, and so a lot of you guys have been kind of neglecting these. So those of you that are watching these have been helping a lot of people. So arc length is pretty straightforward. So I'm gonna start with 24 right here. It's one of those things that we haven't gone over just yet. And so arc length is this means arc length, and r times theta. So if we just look at the unit circle, I talked about it earlier. Let's say it's pi over 6. Pi over 6. That means that the length of this is pi over 6. That is the distance. Why is it the distance? Because the radius of the unit circle is equal to 1. The radius is always equal to 1 on the unit circle. And so, just so you guys know, the points out here at pi on the unit circle, I moved over to the left, -1, and I went up 0. That's my x and y. It's always 1 and 0s on the outside edges of these. So my radius is always 1 on the unit circle. So if I use this formula, the arc length is 1 times theta. This is theta, which is pi over 6. So my answer is pi over 6, or if you put it in your calculator, it's 3.14 divided by 6, and then you get some sort of a decimal. Okay, so on the problems that you have in your homework, they just kind of change this a little bit, where they keep the same concept, but then they go, oh, okay, well, we're going to change this, and we're going to say the radius is no longer 1 and 0. So we're going to open this thing up, and it travels all the way to I can't think. My brain's going dead. 7 pi over 16. I'll make some weird number up here. 7 pi over 16. That's a 16. Sorry, guys. 7 pi over 16. So, but the radius is 12. So if the radius is 12, r equals 12, and theta is now 7 pi over 16, theta is 7 pi over 16, all you have to do is plug it into your formula. So it's 7 pi over 16 and 12, so it's 12 over 1 times 7 pi over 16. These simplify out a little bit, so you get, that's going to be 3, that's going to be 4. So my answer is 21 pi over 4. Or you could plug this into a calculator and get an approximate decimal if you wanted to. Some of the answers are in decimal. So that's really all we're doing with arc length. You're taking the distance around the circle and you're multiplying it by the radius, which is just the hypotenuse or the terminal end. Okay, so let's talk about page 25. That was on page 24. Page 25, we've already talked about this stuff in class, so this is all the homework help for you guys. So if I go with 25, what we're talking about is the trig functions at any angle. So it doesn't matter where I'm at. I can pick quadrant 3. I'm going to pick quadrant 3. I'm over here. And if I draw, I don't have any colored ones. If I draw a triangle in quadrant 3, just like that, I know that my reference angle theta is right there, or A, or whatever you want to call it. But I also know that this is 0 and 0. That's my x. This is my x-axis. This is my y-axis. So if I go this way, I know this is an x value. And if I go down, this is a y value. And this, since it's part of the unit circle, or going around in a circle, this is my terminal side. My terminal side is always the hypotenuse, which is always the radius. So this is really r. Okay? So terminal side, hypotenuse, and radius, they're all the same thing. Okay? The reason it's a radius is because it's part of a circle. If I drew a circle, it's the radius from the center to the side. It's the hypotenuse because it's the hypotenuse of the triangle that I drew. And it's the terminal side because remember, all angles start here and open up, and I've got my terminal side there. So all three terms mean the exact same thing. All we have to do now is realize that the y side is always my opposite. The x side is always my adjacent. And then the r side is always my hypotenuse. So it doesn't matter what quadrant I'm in, I'm always dealing with an x, a y, and an r. Now the only thing that changes is the fact that I'm going to negative x. Because I went left. From 0, I went left. I went down from 0, so I've got a negative here. So that's where a lot of the formulas come from. Again, we're back to our basic SOHCAHTOA. Opposite, hypotenuse. Opposite over adjacent, tangent. Adjacent over hypotenuse, cosine. So we can figure out anything in any quadrant. Which brings us to the example on page 26, which is -3 and -4. So I'm going to go over 3 and down 4. -3 and -4. So if I draw my triangle to match what I just did, this is going to open. This really saying I open up all the way to here. And my theta is right there. And if my theta is right here, that means I went down y, negative y, negative y. That's -4. And then I went to the left 3, -3. I just need to find my r, or my hypotenuse. And I can do that by doing my a squared plus b squared equals c squared. That's going to be 25 c squared, c equals 5. So there's my 5. Now I've got my opposite, because remember, the y is always the opposite, the x is always the adjacent, and the hypotenuse is always the radius. So I've got all of those pieces together based on what I knew previously, that an x and y is a coordinate. This is my x, this is my y, it's my x right there. It's getting a little like squishy. I needed to get colored pens. Sorry about that, guys. So what we need to really focus in on is that we have 3 components to everything. My x value, which is the adjacent side. I keep saying that over and over. My y value, which is the opposite side. And my hypotenuse, which is always the triangle, the back side of the triangle, which is always the radius, which is always considered the terminal side. Those are vocabulary terms that you need to start interrelating together. Radius, hypotenuse, terminal, they all mean the same piece. That's going to take us through 26. It's going to take me to 6:15, and it's time for me to get out of here because I just got done with practice. I'll see you guys tomorrow. Have a great evening.